Hi, in this video I'll try to introduce the concept of inertial frames and non-inertial frames. It's a difficult topic to cover in 4 minutes, but we'll make a quick beginning here. In the inertial frame is a kind of location from which if we observe a motion, it should be possible to solve that using the simple laws of physics or simple equations of motion. The moment we need complex equations to solve the motion, it becomes a non-inertial frame. Now the whole paradox started because scientists thought that the stars are fixed and can be taken as a fixed reference. Later on it was proved that the earth itself is rotating and revolving around the sun, and the whole galaxy in which we live is rotating. And in fact there is a debate that the whole universe may be rotating. Therefore it was decided that nothing really is fixed in the universe. So scientists needed to have a fixed reference for our practical calculations on planet Earth, and the concept of inertial frame was created. If you want to calculate the velocity of a car going from point A to point B, we don't want to be considering the rotation of the Earth and the motion around the sun and so on. So I hope you agree with that logic. Now, for example, if a car is moving from point A to point B, we can solve it using the simple laws of physics. If we look at that standing from the sun, we'll see the car moving on a curved path around the Earth and also going around the sun. That would be a complex spiral. We cannot solve that using Newton's laws of motion. Now, if we also move with a constant velocity along with a car or a bike that's moving with a constant velocity, that's also considered as an inertial frame. The inertial frame doesn't mean that we should be stationary. So this is a point to remember, that we could be moving, but we should be moving with a constant velocity. And the laws of motion can be adjusted to take care of that. That's not an issue to solve the motion. Now let's look at a sketch. Now on the top we have a box at rest and an observer looking at the box. Both are at rest, and the ground on which they are standing is assumed to be stationary and not rotating with the surface of the Earth and moving around the sun and all that. Therefore, that's an inertial frame of reference. Below you have the observer moving at a small velocity v1. The box is moving to the right with a larger velocity v2. That's fine. That can also be considered as an inertial frame of reference because both these things are having constant velocity and not accelerating. Now if we look at an observer who is accelerating towards that box with a large acceleration a1, and the box is moving to the right with a uniform velocity v2, then from our point of view we see both the objects moving from left to right, and of course the observer getting closer to the box. From the observer's point of view, he'll see the box coming towards him or her. That makes it a non-inertial frame of reference. Rotary motion is another example for a non-inertial frame. If we are standing outside and looking at that car moving around that blue circle, the car would be moving